Okay, so in advance, I want to apologize for the visual quality of this video. My setup is not really designed very well for what I'm trying to do here, which is sharing a whiteboard example. But actually, some things are much easier to show using a whiteboard than they are on screen. So what we're doing now is we're talking about the binary search algorithm, which comes up in GCSE and A-level, different kind of levels of complexity, but across all the boards. It's an important algorithm to understand, and it's actually a very clever algorithm. I'm going to show you basically how it works. So let's say we wanted to find this item here, 22. Now, it's really important that you understand the difference between the position within a list and the actual value of the element in that position. Now, this is a distinction that goes right back to maths as well. If you've ever done stuff with sequences in maths, it can be very confusing until you get very clear about the fact that you've got a position, like when you're doing the nth term or something like that. You've got a position. Normally this would be like the first position, second position, third position, but because we're in Python, this is actually position 0, right? So in position 0, we have value 7. That's really important you understand that, okay? And in position 1, we also have value 7. And in position 2, we have value 22. So as long as you're always clear about whether you're talking about the slot number, i.e. the position or the index within the list, and the value that's contained within that slot or position or at that index, then things are going to be a lot clearer than they would be if you were conflating those two issues. So that's the first thing, okay? So we're looking for our target of 22, and we start off with 2 pointers. So basically we have a value, I'm just going to call it L for lower, and we have an arrow for higher. And again, you need to understand that these are referring to the indexes, not the values. So the value of L here is at 0. And the value of H here is 9 because there's 10 elements and we're starting counting at 0, okay? Then we calculate the midpoint, and we do that by adding lower and higher, which is going to give us 9, and we do integer division by 2. Now that comes out as 4, okay? It's the same as in pseudocode using div, which means the quotient. So throw away the remainder and just keep the whole number part when you do the division, okay? So div or double slash means integer division. Okay, so that means we want position 4. So that means the item in position 4, 0, 1, 2, 3, 4. That's this one here. So this is our first midpoint. Okay, and then we basically just have to decide whether this is the one we're looking for, in which case we're done and we exit. So if the value we were looking for was 47, then that would be the algorithm finished, okay? But it's not, so we then need to decide what to do next. Now, we can see when we do this visually that the element we are looking for is lower than that midpoint. So what we actually do now is we move our higher pointer and we move it to this side of the place we just checked. Sometimes you see this in textbooks and examples that you find online, that they move this to the midpoint, but that makes no sense because we've already checked that position. So we actually now move to here for our high, yeah? And then everything over here can be ignored now. Okay, so there's probably a lot of stuff on the board that's already getting confusing, so let's clear some up. Okay, so now we're basically doing this pincer movement, okay? So I don't know if you can see my fingers. No, that's not going to work very well. But you're kind of pincering in from the sides towards the target value, okay? So we've now got, it's called divide and conquer because we're basically going to apply the same algorithm to this smaller problem. So we basically discard everything here, it's gone, right? And we're now applying the same algorithm to this smaller list on this side, which now has only 4 elements. Value of H, 0, 1, 2 is now 3, okay? So then we do the same thing, we find our midpoint. So our midpoint is going to be 0 plus 3, right? Divide by 2, and I suppose I should put brackets in to show that it's actually the whole thing that's been integer divided by 2. Okay, so 0 plus 3 divided by 2 is the same as 3 divided by 2. The integer part is going to be 1. Okay, because it's 1.5, we just want the integer part. So the one in the value in position 1, 0, 1 is 7, which is not the one we're looking for. Okay, so what do we do next? Well, the value at this new midpoint, okay, so this is the new midpoint here, is too small, okay? So what we now do is, because it's too small, we move our lower pointer, okay? And we move it to the side, to the right-hand side now. So this then becomes our lower pointer, okay? Which is, the value is equal to 0, it's 2. Okay, so lower is now position 2. You might be lost at this stage. Okay, it's quite easy to get lost. Even while I'm explaining it, I'm having to think and keep track of what's going on. So you might have to go through this process a few times until you're confident with it. But now we've got a smaller problem. So this here's gone. Yeah, we've divided and conquered. We've got rid of all of this now. We've just got this 2-element list left. Okay, with 22 and 37 in it. So we're going to apply the algorithm again. And we're going to find the midpoint by doing lower plus higher divided by 2. Okay, so that's going to be 5 integer division with 2. That's going to come out as 2. So our new midpoint is 0. By the way, the indices don't change. So even though I've crossed these out, which probably wasn't a great choice of way of describing it, but it's too late now, the actual indexes don't change. This is still 0. This is 1. This is 2. So now our new midpoint is this 22. Okay, and because 22 was our target, then in fact we have found the item we were looking for, and we can exit our algorithm. Okay, so again, apologies for the mess and for the presentation, but hopefully this helps you to understand the basic principle. So you have this kind of pincer movement between the low and the high pointers, and each time you select a new midpoint, you check that midpoint. If it's the value you're looking for, then you're done. You can exit the algorithm. Otherwise, you move either the lower pointer to 1 space further than the midpointer, or you move the higher pointer to 1 space lower than the midpoint pointer. Yeah. Hopefully that was helpful. Let me know.